Rounding a number up or down to the nearest integer depends on the fractional part of a number. So when we convert Fahrenheit into Celsius, the fractional part will come from the remainder of this expression. Since we're dividing by 9, the numerator of the fractional part can be found by finding the mod 9 residual of f minus 32. There are 9 mod 9 residuals which repeat as f increases. We could try to find a general expression for the Celsius temperature after it has been rounded in terms of K, but instead we can try the first 9 values of f, and after that the mod 9 residuals are going to repeat. Since our Fahrenheit temperature starts at 32, we'll use the first 9 values of f starting with f equals 32. So our original Fahrenheit temperature is 32 degrees. When we plug it into this first formula, this is the same as 0 degrees in Celsius. Converting it back into Fahrenheit, we get 32 degrees. This, of course, is the same as its rounded temperature, and it's the same as the original temperature. So this is our first success. Now we'll start with 33 degrees. This converts to 5/9 in Celsius. This fractional part is greater than a half, so rounding our Celsius temperature rounds up to 1. We'll convert this back into Fahrenheit using our second formula. We get 9/5 plus 32. This is 33 4/5. Our fractional part is greater than a half, so our rounded Fahrenheit temperature is 34. Comparing to our original Fahrenheit temperature, we see that this fails the conditions. We'll go on to an original temperature of 34 degrees. Converting to Celsius, this is 1 1/9. The fractional part here is less than a half, so we're going to round down to 1 degree. This is the same as what we had before, so we can go ahead and skip to the rounded part of our Fahrenheit temperature, which was 34 degrees, and that matches the temperature we started with, so we have another success here. If our initial temperature is 35, this converts to 5/9 times 3, or 1 2/3, which rounds up. So our Celsius temperature is 2. We'll plug this back in to calculate the Fahrenheit temperature. Our fractional part is 3/5, which is greater than a half. So this is going to round up to 36. Checking, we see that this is different from our original temperature and it fails. We'll go on to 36 and calculate the Celsius temperature. 5/9 times 4. This is 2 2/9, so this is going to round down to 2 again. Starting from here, we see that our rounded Fahrenheit temperature is also 36, same as what we started off with, and another success. And we'll go on to 37. This is 5/9 times 5, or 2 7/9, which rounds up to 3. We'll plug this back in, and our fractional part is 2/5, so we're going to round down to 37, and that's the same as what we started, so another success. 38 degrees, 5/9 times 6. This is 3 1/3, which is going to round down to 3. Same as above. When we plug this back in as before, we get 37, not the same as what we had before. When our temperature is 39 degrees, we get 3 8/9, which is going to round up to 4 degrees Celsius, and then we'll convert it back. So our fractional part is 1/5. So that's going to round down to 39 degrees, and that's what we started off with, and another success. Last one, 5/9 times 8, 4 4/9. This is going to round down to 4, same as before. So our rounded value is again 39, and not the same as our original. So in our first 9 integer values of Fahrenheit temperatures, we have successes when they equal 32, 34, 36, 37, and 39. In mod 9, these correspond to 5, 7, 0, 1, and 3. We're going to count groups of 9. So when F0 is 40, this is 4 in mod 9. So I want to find the largest mod 9 residual that's less than 1,000. We can write this algebraically as 4 more than a multiple of 9, and it's going to be between 32 and 1,000. Solving for x, and over here, and since x is an integer, it'll be between 4 and 110 inclusive. So the largest temperature in these groups of 9, starting with F equals 32, is 994 degrees. So we'll also have a success when our starting temperature is the next degree up. That'll be 995. Skip one, and then 997. Skip another, 999. and the one that immediately follows 1,000. So counting the number of groups of 9, there's 107 of them, and in each of them there are 5 temperatures that succeed, so we'll multiply by 5, and then we'll add on these last 4. This gives us our answer, 539. If you'd like me to solve any other math contest problems, please leave them in the comments.